Assalamualaikum. My name is Nurhudana Jiha.
Hi, my name is Nur Izzati binti Jeffrey.
My name is Putri Nadia binti Kamal Zaman.
My name is Nur Ain Natasha binti Muhammad Rasif.
So, first thing first, in log-normal distribution, I'm going to explain generally about the log-normal distribution. Okay, log-normal distribution is a transform data, which we put log to the data and the data as a normal distribution. This distribution follow Gaussian distribution properties, which is normal. As for example, an investor will use a large data and they use log-normal distribution to model expected future stock price. Then log-normal distribution is used because it is always positive, even some rates of return are negative. And this technique of using the log-normal distribution is called standard scaling. The graph of the log-normal distribution is almost the same as Gaussian. Okay. This is the graph, which have bell shape. And this one is the graph for the log-normal distribution, which is skewed to the right.
The log-normal distribution is generated by function exponent x, where x is normally distributed. So, from log-normal to normal distribution, we can learn the FT, and from normal distribution to log-normal, we exponent the x. So, we move to log-normal distribution in reliability concept, where we have two forms, which is probability density functions, PDF and CDF. This formula FT, small ft, is the PDF of the log-normal distribution, and if we want to convert to CDF, which is cumulative density function, capital FT, we need to integrate the FT from 0 time to p time.
Okay, from here we can see that this is the formula for the PDF and this is the formula for the CDF. So the TF equal to e power of x has a log-normal distribution with the parameter of T50 equal to e power of mu and sigma. So the population of the failure time x equal to ln TF, which is TF is a failure time, is normal with the mean mu equal to ln T50 and the standard deviation. The new parameter is mean of log distribution if the new parameterization is used. So the log-normal PDF is this one. From here we can see that the t is actually referred to the x minus delta and the ln T50 is actually nu. So next we proceed with the example of the PDF graph for the log-normal distribution. Okay, so from here we can see that this is the sigma equal to 0.5 and this is the graph for the sigma equal to 1. So this is the graph for the sigma equal to 2 and then this is the graph for the sigma equal to 5. So from here we can see that the difference of the shape is refer to the value of sigma, which is sigma is represent the shape of perimeter, which is it is also a
Okay, so for the PDF graph, we can see that it start with the 0 and increase to the mode and decrease after all. And the degree of the skewness increase when sigma increase and given nu is constant. And the degree of skewness also increase when nu is increased and given that sigma is constant. So this is the example for the CDF graph for the log-normal distribution. So here we can see that this is the sigma equal to 0.5 and this is the graph for the sigma equal to 1 and this is the graph for sigma equal to 2 and sigma equal to 5. So from here we can see that the curve of the graph will be at the end it will be moderate, and from here we can conclude that the highest the value of sigma, the lowest the gradient of the curve. Okay.
I will be presenting about the application of log-normal distributions.
Okay, next I'm going to differentiate between normal distributions and log-normal distributions. The graph will be just like this. I'm going to draw it for you. We have y-axis and x-axis, and the normal distribution will looks like this, which is a bell shape. Meanwhile, this is y-axis. Okay, meanwhile the log-normal distribution will look like this, which is it was skewed on the right side. This is how to differentiate the distribution. This is the log normal distribution, or in other words, we call it natural log. Meanwhile, this is the normal distribution. Distributions in a bell shape. And natural logs, it's only happen if and only it's normally distributed, or we call it log normally distributed.
Okay, next is the application for log normals. Commonly, log's normal distribution was used on a stock price per share or rate of return on stocks, earnings per share (EPS), or coefficient of variance (CV), and also for option pricing, and also other application that their distribution where their distribution is skewed, then we will use the log normals application on it. Okay, for examples, in a yearly population growth, the growth rate is a random variables, because the growth rate varies in response to the annual fluctuations in economics. That's why usually in the, for example, yearly population growth, we will use the log normals distributions for its calculations, or we call it for its application.
I am going to give a simple example of calculation for log normal distribution.
For the example, the question says that a population of components when tested at high laboratory stress fit according to a log normal distribution with 250 on 5,000 and standard deviation of 0.7. The question asks to find what the percent of failures are expected on 2,000 hour test. So based on the question from the book, we can extract the information that given, which is T50 is 5,000, standard deviation is 0.7, T is 2,000. So we need to find what percent of failures. Okay, by using the formula of FT equal to P ln T minus mu over standard deviation, where mu is ln T50. So the formula is FT equal to P ln T minus ln T50 over standard deviation. To find the failure, we use RT equal to 1 minus FT, cumulative distribution function. We insert the value that we get from the equation into the formula and we get the answer. This is the percentage of failure. We can leave the answer just like this.